Question number 5 here might be slightly challenging but still doable. It's on volume and area. So without further ado, let's do question number 5a. A cylindrical block of metal has radius 10 cm and height of 30 cm. Calculate its volume, leaving your answer in terms of pi. So how do you calculate the volume of a cylindrical block of metal? So what you do is you take the surface area, which is the base area, in this case is the area of a circle, right? Because a cylindrical block of metal is actually in this form, right? So this base area is in the form of a circle. So this will be my radius r, correct? In that case, so this will be my height of the cylindrical block of metal. So pi times the radius, which is 10 cm, square the radius. Then you multiply by the height. You get the volume of the cylindrical block of metal, which in this case, because the question asks us to leave our answers in terms of pi, so we are not going to evaluate the pi. So 10 square is 100. So pi times 100 times 30. So 100 times 30 is 3000. So it's actually 3000 pi cm cubed. And we are done with 5a, rather straightforward. Now 5b, the block of metal is then melted and recast into 6 similar rods of height 15 cm. Show that the radius of the base area of one such rod is 5.77 cm. Correct to 3 significant figures. Okay? So because we are melting the block of metal earlier, so we use its volume earlier, which is 3000 pi cm cubed. And this is melted and recast into 6 similar rods, but this time of height 15 cm, right? So then it will be 6 of them multiplied by pi r square. Okay, we don't know the radius, so it's r square, and this time height 15 cm. Okay, so this will be 3000 pi equals to 15 times 6 is 15 times 6 is actually 90 times the pi times the r square. Cancel the pi. Okay, so in this case, r square 90 I bring over is divide. So 3000 over 90, which is equals to 300 over 9. So if you want to find the r over here, you take the square root, but you must put a plus minus. Okay, square root plus minus square root 300 over 9. So you get 5.77 cm, rounded off to 3 significant figure, or minus 5.77 cm. So 3SF. Okay? So before that, sorry, I shouldn't write like that. So it should be 5.7735 cm. 5SF first for the intermediate working, or minus 5.7735 cm. And then you round off to 5.77 cm, 3SF, or 5.77 cm minus over here 3SF. But because radius is length, right, we cannot have negative, so this is rejected. Okay, so that's for 5b. Okay, so now we know that r is 5.7735 cm, right? So we are required to use this for 5c. So we use the intermediate working when we are required to use the previous answer that we have derived. For another answer, you have to use the intermediate, which is the 5SF values. So the diagram over here shows the cross-sectional view at the side. If you look at the side, right, this will be the view of a box holding the 6 rods. The box is in the shape of a cuboid and the rods just fit into the box. Okay? Calculate the empty space in the box. Okay, but before we calculate the empty space, right, let's calculate in terms of the area here, the empty space of the area here. Okay? As I have highlighted in red over here, let's calculate the area first, shall we? So in this case, what we're going to do is we are going to ask ourselves, what is the length over here? So we know that the radius here, right, is 5.7735 cm, correct? So in that case, the radius, we can derive the length using the radius. So there will be, so this is the radius, this is the radius, this is the radius, this is also the radius, this one as well. So you can see that there are 6 of them, right? 6 of the radius. So that would be my length. L equals to 5.7735 times 6. Which means that my length will be 34.641 cm. And my breadth is actually equals to 5.7735. Over here, there will be 4 times of the radius to find the breadth. So times 4. So 5.7735 times 4. This gives us 23.094 cm for the breadth. Which means that the area of this cross-sectional area will be equals to 34.641 times 23.094. Okay, we don't evaluate this first. Now, earlier we have found the radius of the base area of one such rod. So actually, we know the radius here, right, which is 5.7735 cm. So what we can do is for these 6 shaded circles over here, okay, it will be area of 6 shaded circles will be equals to 6 times pi of each individual radius of the circle, which in this case is 5.7735 squared. 6 times pi r squared effectively. So if we take the area of this so-called rectangle, okay, minus the area of the 6 shaded circles, then we can find the empty space area, which is equals to 34.641 times 23.094 minus 6 times pi 5.7735 whole thing squared. So by taking the area of the rectangle minus the area of the 6 shaded circles, we can find the empty space area, which in this case, this is equals to 171.681 cm squared. Now, because this is not our final answers, we don't have to round off to 3SF yet. So now we know the empty space area, right? And we know that the height is 15 cm for each rod. So then we can take this empty space area, which you can think of it as the cross-sectional area. Okay, we multiply this area with the height of the rod. So the empty space in the box is actually equals to the cross-sectional area, which is the empty area, 171.681 times 15. So this is equals to 2575.215 cm cubed, rounded off to 3 significant figures. For the final answer, remember to round off to 3 significant figures. It will be 2580 cm cubed, rounded off to 3 significant figures. So my number 7 over here is a 3 significant figure. Look to the number to the right, which is 5. We round up. So 7 plus 1 is 8 over here. Then we write a 0 over here. So that sums up for question number 5. Okay?